Slide 17 has a single point cutting tool video which is going to be quite useful here. Remember, in your workshop practice you have also used a single point cutting tool. It means that cutting edge is a single one. So let's look at this particular video here.
The selection of a cutting tool is probably the most important decision a machinist can make. We're going to cover some of the basics, but I urge everyone that intends to use a lathe to learn as much about cutting tools as possible. They're the key to the quality of your work. Lathe tools are made of many different types of materials in many sizes and styles. The three types we're using today are, from the left, high-speed steel tools, carbide tip tools, and on the right, carbide insert tools. High-speed steel tools can be used for many turning operations on all but the toughest alloys. The tools are sold as blanks in many sizes and grades. The machinist grinds the point of the tool depending on the type of metal he's cutting and the type of turning operation he intends to do. A good machinist handbook will give you the standard guidelines for grinding high-speed steel tools. The cutting edge of a carbide tip tool is brazed to the end of a steel shank. The shape of the cutting edge, its profile and cutting angles are manufactured into the tool. A little cleanup on a green wheel, a silicone carbide grinding wheel, and the tool is ready to go. Cemented carbide will handle much more heat than high-speed steel, so carbide tools are able to cut tougher metals and cut at higher speeds. Cemented carbide is also used to make small inserts that are clamped to a tool's shank. This style insert is manufactured with a cutting edge on each of its three sides. After an edge is dulled, the insert can be unclamped and rotated to the next side. After all the edges have dulled, the insert is thrown away and replaced by a new one. Although this type of cutting tool was designed for the demands of high production work, it's really a great tool for the beginner because it allows even the person with little or no tool sharpening experience the ability to easily maintain a properly formed, sharp tool. No matter what type of material the cutting tool is made of, it's the shape of the tool that determines how it can be used. The profile of the tool's point determines the type of cut the tool is designed to make. The location of the cutting edge on the point of the tool determines the direction in which the tool will cut. Turning and facing tools are either right or left hand tools, depending on which side of the tool's shank the cutting edge is ground. Right hand tools cut from right to left because the cutting edge is on the left side of the tool's point. Facing from the center of a part to the outer edge, cutting right to left, requires a right hand facing tool. Left hand turning and facing tools cut from left to right. Cutting away from the headstock in a turning operation or from the outer edge to the center in a facing operation. The cutting edges on these tools are on the right side of the tool's point. Sending a tool straight into a workpiece is called a plunge cut. This type of cut requires a tool that has the cutting edge square on the nose of the tool. Here we're using a high-speed steel cut-off blade and holder. The position of the cutting tool in the tool holder is very important. Tools should always be placed as far into the tool holder as possible to give the cutting edge adequate support and to reduce the possibility of the tool vibrating. In the case of a boring tool, only the length needed to clear the hole should extend out beyond the tool holder. The height of the tool should be set to match the center of the lathe axis. A lathe center placed in the tailstock can be used as a gauge to set the height. On this tool holder, shims and spacers are used to raise the tool. The tailstock is also used as a tool holder for drilling, reaming, countersinking, and thread tapping operations on the lathe.
Okay, so I hope that everybody must have enjoyed this video. So we have seen that this particular video talks about what kind of different cutting tools we are going to have in this particular machining process. Okay, so the commonly used materials are high speed steel tool, which basically have iron, carbon, and we are also using some kind of alloying element like tungsten and molybdenum. So they are typically used for relatively low speed application. For all kind of industrial application, people are mainly using either carbide tool, for example like tungsten carbide, or something called cemented carbide, for where we are using cobalt as a cement to bind these tungsten carbide together. So this is called cemented carbide. Okay, so these cemented carbide tools are mainly used in the industrial applications here. Now if you go to the next slide, okay, beside this machining process, there's another process or another technique which is getting very popular. This is called additive manufacturing or 3D printing. I'm sure that many of you must have heard about this 3D printing. Okay, so earlier this 3D printing were mainly for polymer materials, but recently many companies are trying to build up this 3D printing process for also for metal process. Okay, so both polymer as well as this metal printing process are used, basically they use a layer by layer manufacturing concept. So what happens here in this technique, first you have to make a 3D object, okay, by using conventional CAD software, and then this particular model, 3D model, will be broken into several layers. Okay, and now you have to manufacture each layer by layer. So what happens is that, suppose we are talking about this metal based 3D printing. So what happens is that you have this metallic powder which is basically lying on the bed, and then we are providing energy through a laser process. Okay, so what happens is that due to the laser here, these metal particles, they will basically bind together, okay, and they will create this particular layer here. So if you can move this particular layer by layer here, you will be able to create different kind of a layer process. So depending upon what kind of process you have, there are various categories of 3D printing process are available in the market. So I would strongly encourage you to go through this particular link, which basically highlights about this video here. Okay, so with this I would like to close my first lecture. So what we have learned in this particular lecture is the importance of manufacturing process. What are the different classification of manufacturing process, for example shaping process, property enhancing process, or surface modification process here. Then we have seen that how the machining process are different, little bit idea about conventional machining process and non-conventional machining process, and idea about the basic terminology which is used in the machining process, which is cutting tool, workpiece, and chip formation. Okay, so before I close this lecture, I like to highlight a very important and bit funny things. So this is called major blunders across the technology area. Okay, so if you see all the famous persons have also done some kind of major mistakes. Okay, so everybody has I hope that heard about Thomas Watson. So in New York we have a very nice, very famous research center. This is called TJ Watson Center here, and this is the prediction of Thomas Watson. I think there is a world market for maybe 5 computers. Another one, Lord Kelvin, everybody is familiar with him also. And what does it say in 1895? Heavier than air flying machines are impossible. Okay, so the point here which I like to highlight here, so even these all wise persons, they were failed to understand the true manufacturing capability of future products. Okay, so again my recommendation is that go to this particular website here and try to find out what kind of major blunders have been made by these guys. Okay, so I'll stop it here. If anyone has any question about this particular lecture, please contact me on Wednesday between 2 to 3 p.m. Okay.